All right, hello there. So for this lesson, I want to talk about some stuff that you learned in Algebra 2. So Algebra 2, so this is a little bit small, but in Algebra 2, you learned about all these different functions, cube root functions, square roots. I just want to go over the pictures of those things and take a look at what you already know from that. Okay, so when you have an absolute value function, I need you to remember that that was a V-shaped graph. All right, and the most basic thing is y equals absolute value of x. All right, a quadratic. Another word for quadratic is parabola. All right, and remember that that is a U-shaped graph. And so, the most basic parabola is y equals x squared. So I'm just drawing I'm not drawing a perfect graph right here, but you get my meaning. It's not going to be great, but you can remember. All right. So cubic function would be y equals x to the third, and it's like a little snaky graph that comes up, goes to the origin, and snakes over to the right. Okay. And then you guys had exponential functions. An exponential function, this was like y equals, let's say, 2 to the x. That 2 down there doesn't have to be that, but I'm just going to do, it could be like a 5 or a 1/2, or remember you could have growth or decay. So this function, it went along the x-axis and then it rose up really fast. And remember, an exponential function has an asymptote. It has a horizontal asymptote of y equals 0. Okay, then there was a square root function. A square root function is kind of like half of a parabola on its side. It starts at 0 and goes up like that. So that was like y equals square root of x. And then you had a cube root function, so it was the opposite of the cube function. So that would be a cube root function with a little 3 right here. And that one, it snakes from the side, comes up through the origin, and goes over. And then finally, finally you had a log function. So now some of these later ones, that was in the springtime when we were out of school, and so whether or not you pay attention during that time, I don't know. But anyway, a log function looks like this. It's y equals log of x. It comes up next to the y-axis, goes through 1, 0, and kind of curves over like this. And remember, that one has a asymptote right here of x equals 0. And then the rational function, those are the functions. It was like y equals 1 over x. They had horizontal and vertical asymptotes. So the most basic one looks like this, kind of curves around, and then this one curves around down here in the third quadrant. And then this had both a horizontal and a vertical asymptote. Okay, and so that was x equals 0. X equals 0, and this one up here then is y equals 0. So just hopefully you remember those, or most of that looks familiar to you. But anyway, so on the next page I have basically I have like this already filled out, but what's happened is I've put some things about it that you need to remember for transformations. All right, so all the transformations are explained right in the middle of the page here, in this little piece right here. All right, and we're just going to go over some basics here. We don't have to know like every single piece, and we don't have to know everything about all these graphs, but I want you to remember some things. All right, when you have something inside your parentheses or your absolute value bars, or like here, or inside the radical, okay, or anytime something is with the x, there they all are. This is going to move you from side to side. So it's going to take a graph like the absolute value, and let's say it moves it to the right or moves it to the left. Okay. Now, if it moves it right, that means it would have to be a minus a number in there, and if it moves it to the left, it would be plus a number in there. Okay. And then we have things on the outside. So this piece on the outside, this guy, this guy, this guy, anytime you have something on the outside of a problem, that's going to move you up or down. So if you had like plus 5, it would take this absolute value graph and move you up 5 spaces. Okay. Then you have this number in front right here. So that thing in front right there, a couple things can happen with that. Depending on what value a is, it could be a stretch or a shrink. So remember that your absolute value function might have gotten skinnier, it might have stretched, or it might have gotten like really wide, and so that was called a shrink because things are lower to the ground or like lower to the x-axis. And then what also can happen is that that thing can be negative. If there's a negative in front of that, remember that that turns your graph upside down. It reflects it over the x-axis. Okay, so those are just some basics, and we have gone over those the first couple days of school, and but everybody was a little bit rusty on that. So anyway, this is like a cheat sheet about that, but let's go on and do some examples. All right, so I'm just going to try to use every one of these functions and try to do a little something different. All right, so let's do the first example. Let's have y equals absolute value of x plus 3, and let's do minus 1. So since this is 3 is on the inside, we're going to be moving it side to side. So it's going to move it left 3, and this part's going to move it down 1. Okay, so I would take a V shape. I'd go left 3 spaces and down 1. It will put me right here. That's my vertex. And then the sides of this graph go up 1 over 1, up 1 over 1, and the other side, same thing. Okay, so I just want you to remember left 3, down 1, and those are the transformations. Okay, all right. This next one, why don't we do a graph? Let's see if I remember, like a parabola. All right, why don't we do negative and then put x minus 4 and put a square. Okay, so all that's happening here, this negative right here is causing you a reflection. And I want you to put in the Ed puzzle, what is this doing to your graph? All right, so that's doing to your graph, that's moving to the right 4. So I go over to the right 4, and instead of drawing a U shape facing up, I'm going to draw one facing down. So draw one facing down. And I'm not being too particular about that. We're just trying to get the general shape. Okay? All right, so next, let's do a cubic function. So a cubic function would be if you had something like y equals, and let's say we have x plus 4 to the 3rd, and then let's take this plus 2. Okay, so again, remember, this moves you to the left 4, and you tell me in the Ed puzzle, what does this do to you? All right, so it moves you up 2. So I would go to left 4 and up 2, and that would be the center of my graph. And remember, a cubic function starts kind of low and then snakes up to the right. Okay, so I'm not going to see that much of it because it's off the graph, but it kind of starts over here and snakes up to the right. And if you ever needed to know this stuff, or like needed a graph of these things, you could always go to Desmos and do that. And so if I go, let me find my Desmos app, there it is. So what was this, x plus 4 cubed? So you go ahead and type in y equals, put some parentheses, and you got x plus 4. And then let's put a power of 3. And, oh, I forget what it was. I think it was plus 2, if I'm not mistaken. But, oh my gosh, I did it wrong. Anyway, plus 2, I'll go back and fix it. I was doing a cube root function. I'm sorry. This is a cubic function. I'm sorry if I confused you. It's late at night here. You can see it's 9:30 at night. All right. So anyway, I'll go back and redraw that. But it's still left 4, up 2. Okay, if you need to draw that. Apparently, I need to do that. Oh, where was I? All right. So let me erase this picture. I'm sorry if you were like messed up by that. So it's still left 4 up 2, but, and this is not right, that's a cube root. And so it's coming up here and going across. Okay, all right. So let's see, how about let's do a square root function. So I got y equals, let's do negative, and then we have a square root of, let's say, x minus 3. And then let's put a plus 1 right there, okay? All right, so remember, a normal square root function starts here and goes up, okay? So this guy, this is going to cause a what? So tell me what that R word is. All right, so that's going to cause a reflection. This is going to cause you to go left 3 and this guy up 1, okay? So, nope, not left 3. Sorry, my bad. Boy, I'm doing bad here. It's going to cause you to go right 3. All right, so I go right 3 and up 1, there I am. So normally I would draw the graph going up like this, but I'm going to flip it over. So it's going to come down instead. So it's going to come down this direction. And again, you know, you can always go to Desmos if you want to confirm what something looks like. Okay, all right. Let's see if I can do the next few correct. All right, so let's do an exponential function. Let's say we had y equals, how about 2x minus or plus 1, and then let's put a minus 4 on the outside. So think back to the normal exponential function. So you have a normal exponential function. This base is a 2, so it's going to be a growth problem. Normally it would look like this. I have to move this thing left 1, and I have to move it down 4. So remember that this thing has a horizontal asymptote. So that horizontal asymptote also has to move. Now if you move it left or right, who cares? But if you move it down 4, that matters. So my new horizontal asymptote is going to be down 4 spaces. It's going to be down here at y equals -4. So that might be a question that you get asked at some point. All right, so we're going to take this spot. It used to go through 0, 1. I'm going to move it left 4. Or I'm sorry, left 1 and down 4. So here I am. I go left 1 and down 1, 2, 3, 4. So I'm right here. I'm always a little bit away from my asymptote. All right, so right there. All right, then I'm just going to draw that picture. All right, we're just looking for a general picture here. All right, and then last one. All right, last two. So I'm going to do a log function. So y equals log. And let's see. Oh, log of, how about just log of x? Nothing else. And let's put a +3 on the outside. All right, so remember, a good old log function used to look like this from that main picture over there, and it had an asymptote at x equals 0. All right, so I'm just going to move this graph up 3 places. If I move this blue graph down here up 3 places, the asymptote doesn't move at all, because the asymptote only moves when I go left or right. So I'm going to keep this thing at x equals 0. And remember, you can also just type in the word log into Desmos. It'll graph it for you. And let's see, this point right here used to be 1, 0. So I'm going to go there, and I'm going to go up 3 places. So 1, 2, 3. And so I'm going to be right there. So that's kind of my linchpin point, and I'm going to draw my graph coming up and over. All right. Okay, so last one. Last one, let's do a rational function. Let's say we have this guy. Let's say we have 1 over x minus 2. All right, so hopefully you know from last class and from your warm-up that you have a problem here. You cannot use 2. X can never be 2. So remember, that creates your vertical asymptote. So your vertical asymptote is moved over to 2. All right, and remember, the original graph looks like this from the main picture, here and here. And my asymptotes used to be right here, x equals 0 and y equals 0. But now you can tell that I'm also moving it to the right 2, and that should make sense because look, it moved over here, x can't be 2. All right, the rest of the graph stays the same. So we're going to still have a horizontal asymptote because I didn't move this graph up or down. And so then I'm going to draw my picture over to the right and over here on the left. So what you're going to have to be able to tell me in next class is you're going to have to tell me the transformations, all this up, down, right, left, reflection, stretch or shrink. And I didn't do any stretches or shrinks on a lot of these because you can't tell, it's hard to tell on if you're not doing on a calculator. But, you know, you be able to identify a stretch or a shrink. And so actually, why don't we just do one more of that of, hang on a second, let me just copy this last page. Duplicate, there we go. All right, and let's just do one of those real quick. All right, so let me erase all this other stuff. All right, so remember a stretch or a shrink. Let's do one with an absolute value. So let's say you had this one, last one. Let's say you had like a 1/2 right here, and then absolute value with x, and then you had a -4 after that. So remember, this is going to make you move down 4. This is going to shrink you. All right? So I'm going to take the absolute value graph, which used to look like this, and I'm going to move it down 4 spaces. Now my slope used to be up 1/1, but now it's going to be up 1/2. So it's shrinking everything down. And then the other side is up 1, back 2. Oh, that was too far. All right. And so you can see what that does is it shrinks your graph down. It like pushes it closer to the ground in a way. So it's much wider than normal. So just remember that. If the number is bigger than 1, that would be a stretch. And if it's less than 1, it's going to be a shrink. Okay. All right, that's it. I'll see you in class.